Hi, good morning. Today we are going to talk about one of the interesting results. Yeah, it is known as Merten's theorem. It deals with Cauchy product of two infinite series. I'll very briefly explain because I expect the viewers to learn something about the infinite series, their sum, convergence, partial sums, absolute convergence, etc. etc. Okay. So if you are not enough required background, please review and then revisit. Okay, so let me share the screen and try to talk about what it is. All right. Okay, so what do we assume? I am assuming that all of you know what is meant by an infinite series. Let us say n equal to 1 to infinity. I will simply write it only as an r term time an suffix n. Okay, it is understood here. Okay, to quickly recall, how do we mean, when do we say this is conversion? Look at the partial sums 1 to n. Then if this sequence is conversion and suppose Sn converges to S, then I call S is the sum of the series and write this equality. Okay, notice that whenever you write this symbol, this is just a symbol. This symbol stands for S. And what does S stands for? It is the limit of the sequence of partial sums. So you cannot directly deal with the infinite series. It's like with you, as you do with finite sums. Okay, you can't do that. Okay, and next thing is, when do I say this is absolutely convergent? I say this is a series of, assume these are all real numbers, it could even be complex numbers. Okay, and when do I say this is absolutely convergent? Look at this series. If this series is absolutely convergent. Now notice that if Tn denotes the partial sums mod a k k equal to 1 to n, then Tn is increasing. Therefore, when this is convergent, if only if Tn is bounded above, right? And where, so suppose Tn is bounded above, then Tn converges to T. What is this T? This is nothing other than LUB of Tn's, the partial sums. Okay, the reason why I'm saying is, so suppose I want to say something like this, mod a k k equal to 1 to n is less than equal to summation mod a n over to 1 to infinity. You cannot immediately say this is a sum of positive terms, so you are adding. No, that's not the right reason. Notice that this is Tn, this stands for T, where T is the least upper bound of all these partial sums. Therefore, Tn must be less than equal to T. That is the reason why this is true. Not because you are adding one extra term. You understand? But for us, Tn less than equal to Tn plus 1, this is a correct statement for all n. Because I am adding one extra positive term, mod an plus 1. But to say this inequality, you have to go back to the definition of the sum of the series. Is that understood? Okay. The next thing we will need is that let's look at an. This is a sequence, and if the series an is convergent, when do I say it's convergent? If Sn converges to S, then I say the series summation an is convergent. Okay, so when this series is convergent, then the sequence an goes to 0. Okay, this is okay. Usually, loosely people would say nth term goes to 0, but the correct way of saying for me would be, given an sequence, form the infinite series. This is the series associated infinite series associated to the sequence. Then if this series is convergent, the original sequence is convergent to 0. In particular, it will be bounded. The sequence an must be bounded. Is it clear? So these are some of the basic ideas I need. Okay, I request you to pause, review, and proceed before we go further. If you have seen it earlier, it's well and good. Otherwise, again, do it quickly. Okay, I may need one or two more things as we go along, but let us do it. Okay. Now, in the general algebra of convergence series, you would have talked about sum, scalar multiples, and comparison tests, etc. But suppose I have two series summation n, assume this is and summation bn, both are convergent. Do you remember what does it mean to say convergent? Okay. So I want to define the product this. And suppose this converges to A and this converges to B, then I want to define the product so that it also converges and the sum is AB. You understand? Okay. A very naive attempt may be to define the product of these two series, maybe something like A1, B1, A n, Bn, n equal to 1 to infinity. But this is not good. Why? Because if it's a finite series, let's say A1 plus A2 and B1 plus B2, okay, and this product will be A1 B1 plus A1 B2 plus A2 B1 plus A2 B2. You understand that? There are terms extra, not only A1 B1, A2 B2. Yeah. So we have to define the product of two infinite series little more carefully. Is that understood? Okay. So it is motivated by polynomials. Hereafter we will assume our series starts with 0. That is 0th term. Okay. Okay. You understand? Right. Okay. Now the partial sums, instead of Sn, I will denote by An to be the partial sums. 1 to n, and this is also 0 to, sorry, 0 to n, bk, that to be bn, and the sum to be a and b. Okay, that means an converges to a, and bn converges to b. Okay, right. Now I want to define the so-called Cauchy product of this series. Okay, this is nothing difficult. You think of the polynomial. Suppose I have a polynomial p of x equal to a naught plus a1 of x, a2 of x squared plus a n of x power n, and let us say q of x equal to b naught plus b1 of x, etc. bn of x power n. Okay, it may be degrees may be different, but you write it in extra zero coefficients. Okay, the typical way you do that. Now, what is the product of PQ? The product of product polynomial Px. This is multiply using distributive law and collect the terms. Therefore, the constant term will be a naught b naught, and that other thing will be a naught into b1x. Therefore, a naught b1 plus a1 b naught. This is x term, and second term will be a naught b2 plus a1 b1 plus a2 b naught. This is x squared, and general term will be, let us look at that. This is a naught bn plus a1 bn minus 1, etc. an minus 1 b1 plus an b naught. This into x power n. You understand that? Therefore, this is a polynomial c naught c1x plus cn x power n, where cn is summation ar into bs, where r plus s equal to n, where and 0 less than equal to r, s less than equal to n, but their sum must always be this. You look at this, 0 plus n, 1 plus n minus 1, and the typical term will be ar, bs, that should be r plus s must be equal to n. Is that clear? So this is the one which motivates us to define Cauchy product of two series. So the given two series an, infinite series this, the Cauchy product is the series Cn, n equal to again 0 to infinity, 0 to infinity, this 0 to infinity, where can you guess what should be C naught? A naught B naught. What will be C1? A naught B1 plus A1 B naught. In general, what is Cn? AR, BS, R plus S equal to N. Of course, R and S greater than or equal to 0. Of course, you can write it as A naught Bn plus AN B naught, as I did earlier. Is that clear? This new series is called the Cauchy product of the two series, summation AN and summation Bn. Is that clear? Okay, quickly review this definition so that you are more comfortable with this. Okay, when you are in doubt, what you should do? You should look for the polynomial and arrive at this definition. Product of polynomials. Right? So what is the theorem I would like to prove? So ideally, I would like to prove if this series is convergent, then the Cauchy product, this should be convergent and the sum should be AB. Okay, there are two things. You understand that? It should be convergent and the sum should be AB. This is what we want to know. Is that okay? Right. Now let's try to prove it. Okay. I don't want to write the statement of the theorem. Do that. Okay. This is one of the good proofs to master. Okay. I will come back to it at the end of the lecture. This uses what I call divide and conquer trick. Okay. We have seen this in the sequence videos. Then it also converges to X. Okay. We had already used a divide and conquer trick here. Okay. Please check the sequence videos. One of the sequence videos will have a proof of that. Okay. Arithmetic averages of a convergent sequence also converge to the original limit. Okay. The same trick, but this is slightly more subtle. The proof here is a little more subtle. Okay. Even though it's again divide and conquer, it's a little more subtle. Okay. So let's directly prove it. So what should I do? Okay. So we have, okay. So I have to prove, let Cn, see this Cn, maybe I should use some other notation because my C, small c and capital C may both look alike. So let me call it gamma n. Is it all right? Let gamma n be the nth partial sum. Sum of the series Cn. This is the Cauchy product. Okay. Now what should I prove? I should prove gamma n converge to AB. Is that clear? Okay. For this, what will be done? You will give me an epsilon. I have to estimate this. So all of you who have seen some of my videos will know I always use the word I want to estimate. So I have to estimate this. Right? For n sufficiently large, it has to be less than any epsilon I want. This is all I want. Is that clear? Okay. Now we want to understand what is gamma. Now what is gamma naught? Gamma naught is just a C naught, which is A naught B naught. What is gamma 1? It is C naught plus C1 C naught. Maybe let me just see. I may need more space there. Let me use C naught. This is C naught. This is sorry. Okay. This is A naught, B naught. This is A naught, B naught plus A naught, B1 plus A1, B naught. You understand that? This is C naught, this is C1, right? Okay, this is just rewrite A naught into B naught plus B1 into A1 into B naught. Is that all right? Now, what is gamma out 2? I'm sorry, I will go slow so that people will see the pattern. That's going to be A naught, B naught plus A naught, B1 plus A1, B naught plus A naught, B2 plus A1, B1 plus A2, B naught. So collect A naught terms, A naught into B naught, B1 and B2. Therefore, B naught plus B1 plus B2 plus, now collect A1 terms, A1 B naught and A1 B1. Therefore, it is A1 into B naught plus B1 plus A2 into B naught. You understand? So proceeding similarly, what will be gamma n? C naught plus C1 plus Cn, that is going to be A naught B naught plus A naught B1 plus A1 B naught, okay, plus the last term will be A naught Bn plus A1 Bn minus 1, etc. Then An minus 1 B1 plus An B naught. Is that clear? So I'll again rearrange it. This is A naught into B naught, B naught, B1 and Bn. Therefore, this is going to be A naught into B naught plus B1 plus Bn minus 1. Here, Bn. Okay, plus what will be A1? See, the terms have to add. Therefore, what will I have? A1 will be, it will start from B naught, but it can go up to only Bn minus 1. Is that clear? And when I come to A naught, it's just B naught. You understand? Right. Now let us try to understand what is this B naught plus B1 plus Bn. That is the nth partial sum of this second series summation Bn. Therefore, this is in my notation A naught into Bn. The next one is A1 into Bn minus 1. Next one will be A2 into Bn minus 2 and so on. Okay. And AR will be AR into B n minus r some term. The last term will be A naught An into B naught. B naught is just a first term B0. That's it. Is that all right? Do you understand this? This is very crucial for our understanding. This is pure algebra. There is nothing. Okay. Good. Now let's, so we are rearranging terms. So let me just write it separately. Gamma n is A naught Bn plus A1 Bn minus 1 plus An B naught. Right? Now what is that I want to prove? I want to prove this converges to AB. Right? Right? That means I have to estimate mod gamma n minus AB. But do I know how to estimate that? No. So I have to rearrange terms so in such a way that I can estimate mod gamma n minus AB. So how will I do that? So now I know how, since Bn converges to B and similarly An converges to A, I know how to estimate mod Bn minus B, mod An minus A. Is that clear? So we do the standard trick now. Of rearranging things. Therefore, gamma n is, I can write as Bn minus B plus A1 into Bn minus 1 minus B plus last term will be A naught into B naught minus B. But what I have done, I have subtracted extra terms. Therefore, they are going to be of the form A naught B plus A1 B so on plus An B naught. A naught B. Sorry. Yeah. An B. Is that okay? These are the terms. But this I can think of it A naught into Bn minus B plus A1 into Bn minus B plus an into b naught minus b plus, let us look at that, the last extra terms are a naught plus a1 plus an times b, but that is nothing other than an times b. Okay, do you understand this? So this is what I will check, gamma n equal to this. Do all of you understand this? This is going to be very crucial for us. Yeah, this is not absolute value, this is modulus. Yeah, now there is some light at the end of the tunnel. What is that? If n is large, then I know how to estimate this is bn minus 1b. Okay, I know how to estimate bn minus b, right? Do you follow that? Yes. Okay. Now what is that I want to prove? Gamma n converges to ab, but let's look at this term. Gamma n equal to something, let me call it Rn plus a and b. Okay. Now I want to say gamma n converges to ab, but let's look at a and b. Where does it converge to? It converges to ab. Therefore, what do you think I should prove? Yes, I should prove Rn goes to 0. Do you appreciate this? Okay. I am rewriting this. Gamma n equal to whatever is there, I write as Rn plus a and b. Now I want to say gamma n converges to ab, but I know a and b converges to ab because a n converges to a, b converges b. Therefore, the product converges to ab. Therefore, to prove this, it's enough if I show Rn converges to 0. Is that clear? Okay. That means I want to show Rn converges to 0. Okay. Pause, review, proceed. So what does this mean? This means I have to estimate mod Rn. Yeah, you need to estimate this, right? Now let's look at Rn. What is Rn? This is a naught. It's easy. Remember, these two should add up. Bn minus b plus a1 b n minus 1 minus b plus an b naught minus b. Is it okay? Now something very interesting happens, right? This is where the divide and conquer comes, trick comes. Let us look at that. If n is very large, okay, I know how to estimate bn minus b, right? But here look at that, the last two terms like this, an times b naught minus b. This may be very large. B naught minus b may be very large. I don't know how to estimate, right? But let's look at an. I know how to estimate. How do I know how to estimate? At present, I know how to estimate an, but I may change my way. Okay. Since summation an is convergent, then I know an converges to 0. Therefore, I know how to estimate mod an. You see that? So you take a term of the kind, something like ak b n minus k minus b, something very interesting. If n is very large, then I know how to estimate bn minus k minus b. If k is very large, the bracket term I do not know how to estimate, but I know how to estimate mod ak. So that means I have to break the sum into, divide the sum into two parts, okay, so that I can manage what should I estimate, mod bn minus b or mod an. You understand this? Right. So if I want both to be big, see, notice that. Have you understood this? Okay. So how do I achieve that? Yeah. Let us again go through. So just we are thinking aloud. Okay. I will at the end indicate how to write a textbook proof if you want. Okay. So if n is very, very large, okay, I know how to estimate bn minus b. And similarly, I know how to estimate mod an. Okay. Right. But Each of the terms has product of two things. Something which involves mod an and something which involves mod bn minus b. So if, and there has to be balance. That you understand? When I look at b term, bn minus b term, then I want n to be large. But then the corresponding a term will be small because it is, this is the term. Look at this term, ak into bn minus k minus b. So when I want to estimate the bracketed term in b, I want n to be very large. Okay, but then the k should not be large, k should be small. But when I want to estimate mod ak, I want k to be very large, but then this will be, n minus k will be very small. So I may not know. You understand that? So the first idea, what should I do? I want both of them in some sense should be large. Yeah. So the basic idea is, so suppose for capital N, okay, then if n is greater than or equal to capital N, suppose I know how to estimate minus bn, and also I know how to estimate mod an, okay, then what I can do is I take my n to be greater than or equal to 2 times capital N. You understand this? Then let's look at, okay, now let's look at the kth term. Kth term is of the form ak b n minus k minus b. Right? This I'm looking at the general term to have an idea. Right? Now if look at this, now I want this term, if my k is less than or equal to n, n minus k will be greater than or equal to capital N. Therefore, bn minus k minus b, this term will be easier to estimate. You understand this? So when k is less than or equal to n, this term is easier to estimate, bn minus k minus b. Okay, but on the other hand, if k is greater than n, then I know how to estimate this term ak, and this will be something bn minus k minus b. Okay, but this may not be, but I know how to estimate this. Is that understood? Yes. Okay, right. Now let's keep that in mind. Okay, let's see what we can do. Okay, right. So let us, again, I don't know which n, epsilon, nothing has come yet. You understand? I'm just still playing how to estimate. This is in a typical classroom textbook. These are the things which you miss. You see a well polished proof which we are going to write soon. You can check line by line, but you may not know what is the intricacies of the proof, how the problem was solved. Okay, how much of thought went into the proof. These are the things. The idea of my lecture, the aim of my lecture is to bring out these kind of inner workings of mathematics. Okay, now let's look at gamma n. So gamma n, now assuming n is greater than or equal to n, this is a mythical capital N. I don't know which n. Okay, keep that in mind. So this is a naught into bn minus b plus I can go up to capital an b n minus capital N minus b. You understand? Up to this is all right because the bracketed b terms are easier to estimate for me. Now comes the next one. This will be an plus 1 into b of n minus 1 minus b, and this will be an into this is yeah, b0 minus b. Is that okay? All right. I'm just trying to write in terms of terms now. Now, since n is greater than or equal to n, let's look at this first capital N terms. Do I know how to estimate? Because remember, n minus n will be greater than or equal to capital N, right? Therefore, I know the bracketed b terms can be estimated, right? Suppose each of these terms is less than epsilon. What is less than epsilon? Mod bn minus b is less than epsilon for all n greater than or equal to n. Suppose that's true. Then the first n terms can I estimate? Yeah. So let me try to estimate these first n terms. Let us give a name so that we don't have to keep saying this. This term, this first n terms, call it S. This, these terms call it T. Okay, all terms where the index for A starts from n plus 1 onwards, greater than or equal to n plus 1. Right? So I want to know how to estimate S. So mod S, an obvious estimate will be mod A naught into mod Bn minus B plus this is less than or equal to plus mod An, A capital N into mod Bn minus N minus B. Is that okay? Right? Now this is less than or equal to epsilon because each one of the B terms are less than epsilon into mod A naught plus mod An. You understood? Yeah. Let us look at alpha n, okay, alpha n to be the partial sum of the series mod An. Mod ak, k equal to 0 to n. That is what I call alpha n. Therefore, the estimate for S, when I break at the nth term, to be very precise, I should write S capital suffix n, T suffix n, but I am not doing it. Okay, this is less than or equal to epsilon times A alpha n. You understood this? So I seem to estimate it. Alpha capital N, sorry. Yeah? Okay. Now let's look at T. How will I estimate T? Now when I want to estimate T, you can see that this will be epsilon. Okay. The obvious guess may be, let us go through the obvious guess, that will be, let me write it summation, less than or equal to mod A k into mod Bn minus k minus B. K running from n plus 1 to n. You understood this? Yeah. Now let us see, how do I estimate this? You may think, okay, I can take epsilon out because for k, k is greater than or equal to n. Therefore, mod ak will be less than or equal to epsilon. So I can take epsilon out, you may think, right? If I take epsilon out, I just want to tell you the obvious estimate why it fails. Okay, if I take epsilon out, what do I get? I get epsilon into less than epsilon into n plus 1 to little n of mod Bn minus k minus B, where k equal to n plus 1 to n. You understand? Now I have no estimate for this. If k is very large, mod Bn minus Bk minus B will be anything. So you, and remember this little n is greater than or equal to 2n, and but then little n can be as large as I want. Therefore, infinitely many terms are going to be, or arbitrarily large number of terms are going to be in this sum, and each of these terms have the form something like mod Br minus B. I don't have any obvious estimate. Do you understand this? So my original idea of saying for k large, if k is sufficiently large, mod ak is less than epsilon, is not going to help me. Do you understand this? So what do I do? See, this is what I call, in the unique divide and conquer trick, there is always what I call a kind of a crude estimate trick. Crude estimate part comes. Here, I have to get a crude estimate. What crude estimate? See, let us look at mod Bn minus B, right? What do I know? I know Bk converges to B. Therefore, mod Bk minus B goes to 0. Therefore, the sequence mod Bk minus B is bounded sequence, right? You understand this? Therefore, there exists an M positive so that mod Bk minus B is less than or equal to M for all k. You understood that? So what do I do is, since I am unable to estimate this mod Bn minus k minus B terms uniformly, I take a crude estimate. Okay, is that clear? Therefore, I can replace this by M. Okay, therefore mod T will be less than or equal to mod Ak running from n plus 1 to n into M. Therefore, this is equal to m into mod a k n plus 1 to n. You understand? But I want to be something like, see, my gamma n mod gamma n is s plus t. Therefore, mod gamma n will be less than or equal to mod s plus mod t. So I want mod gamma n to be less than epsilon. That means I should make sure mod s is less than epsilon or s by epsilon by 2, and mod t is also less than epsilon by 2. Do you understand? That means, okay, this must be something like something to do with epsilon. Maybe m times epsilon. Do you understand? For which n? Remember, this n is not fixed. The small n is not fixed. It is as large as I want, as long as little n is greater than or equal to 2 times capital N. You see that? Therefore, this is almost like infinite series. You follow that? Look at this and look at the earlier thing, the estimate for mod s, which involved epsilon times alpha n, where alpha n is the partial sums of the series summation mod a k, the absolute series. Okay. Now, if I want to make sure both of them are less than epsilon, what is that I have to do? Remember, my original assumption was summation an is conversion and summation bn is conversion. Okay. Will that do? No, because this seems to say something like n plus 1 to infinity of mod a k should be less than epsilon, because this must be true for every n. You understand? Therefore, this must be less than or equal to epsilon. You understand? So, what does this trigger? It should trigger your memory. What condition I should impose? Okay. Pause, review, proceed. So, we have to put an extra hypothesis to prove the theorem. What is that? We assume the series is absolutely convergent. That is summation mod an, the A series summation, okay, is absolutely convergent, which is same as saying this is convergent. Okay. Suppose this is convergent. Okay. You understand this? Suppose this is convergent. Now, are we through? Okay. Because this is the tail of the series. N plus 1 to infinity mod a k is the tail of this convergent series. Therefore, it can be made arbitrarily small. Therefore, times m times epsilon. Therefore, mod t will be less than or equal to m times epsilon. Is that clear? It seems that we have achieved. Right? And now, let us sit back and try to choose n1, n2, etc., etc. Right? What are the things we assumed now? So, we wanted for n greater than or equal to capital N, mod bn minus b is less than epsilon. That I can achieve, right? Given an epsilon, okay, there is a capital N1, so that for all n greater than or equal to capital N1, mod bn minus b will be less than epsilon. But remember, I want mod s to be less than epsilon by 2. Therefore, what do I have? It is going to be mod bn is going to be epsilon into, let's look at this, mod s estimate less than or equal to epsilon into alpha n. You understand? Therefore, what do I want? I want this to be actually epsilon by 2. Therefore, what should I make sure? Choose capital N1 so that mod Bn minus B is less than epsilon by 2 into alpha capital N. Is that clear? Okay. So, let epsilon be given. Okay. Since Bn converges to B, okay, there is a capital N1 so that for all n greater than or equal to capital N1, mod Bn minus B is less than epsilon by 2 times alpha n, alpha capital N. Yeah. Is that all right? Which capital N? Since there is no N1 now, I have to simply say it is N1. You understand? For which N1? I don't know, because I stopped at N1. Are you following me? Please go back. This is Bn. So up to these terms, I want to say is less than epsilon. When do I know that? So when my n is greater than or equal to capital N1, 2N1. You understand? Okay. Okay, this is some. Are you following? There's a slight subtlety. I want you to kind of go through it in a very naive way and try to understand and see how we master that. We overcome the difficulty. Okay, very good. So this is epsilon by 2 into alpha, perhaps n1. I don't know. Okay, right. Now let's look at next. What do I want? I want this tail of the series, absolutely convergent series mod ak to be less than epsilon. So given epsilon, okay, there is an n2, so that what happens? Summation mod ak, k running from n2 plus 1 to infinity. This is less than epsilon by 2 I want, but then remember there is also an m. What is that m? That m is the upper bound for the convergence series summation, convergence sequence mod bn minus b. Therefore, I want this to be less than 2m. You understand? Now what do I want? Let's go back. I wanted n to be greater than or equal to 2n. After that, I can break this. For the s term to be estimated, what do I want? I wanted my n to be greater than or equal to 2n1. But for this t term to be estimated, I wanted my n to be greater than or equal to n2. Therefore, you may think I have to take maximum of n1 and n2. Very good. Take n to be maximum of n1 and n2. Okay, but now there is a problem. If I took n greater than or equal to 2n, now you wrote this, I don't know which n I am getting into. Right? Mod s is less than or equal to epsilon into mod a naught plus mod a n, which is epsilon into alpha n. Which n I am talking about? Yeah? Are you following the difficulty? But there is an easy way out. So what do I do is, since now that I made an extra assumption that the series is summation mod a n is convergent, therefore let the series, sum of the series 0 to infinity, let it be alpha. Now let's look at whatever n you give me, what is the relation between alpha and alpha? In the beginning of the lecture, I already said this always less than or equal to alpha. You understand that? Therefore, let's go back. So what is the estimate for mod s? Whatever n capital N you took, mod s is less than or equal to epsilon times alpha n, but that is less than times epsilon into alpha. If you want less than or equal to, do not break your head about strict less than or etc. Okay. You understood this? Why it happened? Because alpha is the least upper bound of alpha n's. Therefore, it will be less than or equal to here, but this may be strictly less than. Do not worry about it. Is that clear? So now what did I do? It looks I got a proof. Okay. See, this is the way we thought about a proof, and to make sure that we did not make any mistake or there is no logical contradictions in between, it is always desirable to write what one knows as a textbook proof. Okay, that is the kind of verification. It is like, earning money and spending, it keeps on going, right? But when you want to submit it to income tax authority, some chartered accountant should sit and check the accounts properly. You understand? So something like a verification process should become easier. So we have to write a textbook proof now. So how will I write the textbook proof? Next few minutes will be spent on that. Okay. Now you will see the textbook proof will be easy to write, use it to verify line by line, but you may not know. Everything will become very, very mysterious. Okay. So let us go back. What do I want to show? I want to show gamma n minus a and b is less than epsilon. So let epsilon be given. Okay. Then I want to say there is a capital N, so that for all n greater than or equal to capital N, mod gamma n minus a and b is less than epsilon. Okay, if you want AB, again I have to do epsilon by 2 and plus AB 2. You understand? Because mod gamma n minus AB will be less than or equal to mod gamma n minus a and b plus mod a and b minus AB, but that this is mod b into mod a n minus a, etc., etc. You understand? So it's enough ratio. This is less than epsilon. Are you following? Okay. So epsilon. So I have to choose capital N. So what are the things which go? Right? Right. The first thing is, as I said, now let's write the theorem so that we will know. Let an and 0 to infinity and bn be convergence series. Assume one of them is, assume mod an is convergent. Okay, that means you know, if you know absolute convergence, assume summation an is absolute convergent and summation bn is convergent. Then automatically summation an is convergent. Okay, then the Cauchy product an is AB. Assume that an equal to a, bn equal to b. Okay, this is summation an into summation bn 0 to infinity, 0 to infinity. This is the theorem. So we put extra, right? Now I want to textbook proof. Okay. Now you see that even the statement of the theorem, did I write it very textbook way? No. I should say let summation an and summation b and b to convergence series. Assume summation an is absolutely convergent, which is same as saying summation mod an is convergent. Then the Cauchy product of the series denoted by Cn, then Cn is going to be convergent and the sum is summation an into summation bn. This is the textbook way of writing. Okay. Right. Now, so let us set up the notation. What is the notation? Let an be the partial sums of the series 0 to n, bn to be the partial sums of the series bk 0 to n, and let gamma n be the partial sum of the absolute series 0 to n. Is that clear? And let a equal to sum of the series ak 0 to infinity, and b to be sum of the series an 0 to infinity, etc. These are the notation. Okay. What we want to prove? We want to prove gamma n converges to AB. Okay. I claim enough to show gamma n minus a and b goes to 0. Okay. This is left as an exercise. This, okay. I just now I proved it. Okay. In the textbook, they will not even show. It's enough. Okay. It's enough to show this goes to 0. Okay. So to prove that, let epsilon positive be given. Right. Now, what are the things? The moment you give me epsilon, notice that what did we do with epsilon? We wanted epsilon by 2m. We also wanted epsilon by, where did I want? Yeah, I wanted epsilon by 2 alpha. You understand? All these things I already know. Now I put it into use. Okay, let epsilon be given. Let m, okay, be such that modulus bn minus b is less than or equal to m for all n natural number. You will wonder why I want that, right? Okay. Next, what do I do? Let n1 in b such that, okay, what did I want? Modulus bn minus b is less than epsilon by 2 alpha. Is that what I wanted? Yeah. Because remember, alpha is also defined. Okay, maybe it's not defined. Let alpha equal to summation. No, sorry, this alpha n. I said alpha n, but I wrote gamma n. Let alpha equal to summation mod an which is same as saying limit of alpha n. Okay, for all n greater than or equal to n1. And let n2 be such that, what do I want? n2 plus 1 to infinity of mod ak should be less than epsilon by 2 times m. Okay, how do I know all these things? Just because we work through our way. And let n equal to maximum of n1 and n2. Okay, now we claim, what do we claim? For all n greater than or equal to 2n, modulus of gamma n minus an minus b is less than epsilon. Okay, now what is gamma n? Gamma n is the partial sums of the Cauchy product summation 0 to n of ck. Is that all right? Okay, now let's go through the proof. Okay, so modulus gamma n minus a and b, we know is nothing other than series of this thing 0 to n a k and b n minus k minus b. Okay, now we have to write it. I am not writing it. You understand that? See, this has to be proved. This algebra should be checked. Because we have done it, but actually in principle I should write. Remove the mod, simply say that mod. Okay, you understand? Therefore, modulus of gamma n minus a and b equal to less than or equal to summation 0 to capital N of mod ak into mod bn minus k minus b plus summation n plus 1 to little n of mod ak into mod bn minus k minus b. You understood this? Right. Now since n is greater than or equal to n, n minus k will be greater than or equal to n. Therefore, mod bn minus k minus b will be less than epsilon by 2 alpha. You understood that? Yeah. And right. And therefore, the first term is less than or equal to epsilon by 2 alpha into summation 0 to n of mod ak, but that's less than or equal to epsilon by 2 alpha into alpha n, but that is then epsilon by 2 because alpha n is less than or equal to alpha. Is that clear? Now let's look at the second term. This is the second term. Here, what do I have? I have n plus 1 to little n mod ak into mod bn minus k minus b, but each of the factor mod bn minus bn minus k minus b, this is less than or equal to m, therefore that's less than or equal to m into n plus 1 into n of mod ak. Yeah, notice, right? But again, by whatever I said in the beginning, n plus 1 to n of mod ak will be less than or equal to mod ak n plus 1 to infinity. But that's less than epsilon by 2m. Therefore, this object is less than epsilon by 2m. Epsilon by 2. Is that clear? So, I have proved the result. Okay. So, for all n greater than or equal to 2n, I have proved mod gamma n minus a n minus b is less than epsilon, and hence, okay, gamma n converges to ab. Proof is over. Okay, please go through that, refer to my book. Okay, how to write it carefully. But okay, let us stop sharing. So this proof is very demanding. I have seen some experts struggling over that, because you take a book and verify line by line, then if you forget, then it will be difficult in the class, right? But go through this proof. As I said, this proof is little subtle. Okay. And second, this is the second instance of divide and conquer rule. There may be more. Yeah, in fact, x power n by n factorial goes to 0. There also we used divide and conquer rule. Yes. So we had already seen 3 such instances in my video so far. Please review all of them. Okay. This is one of the important tricks of analysis. Okay. There is one more thing, 2 more things actually in analysis. Okay. Once in integration also, we will come to that by and by. So at least revise once more, go slow, discuss with your friends. And let me tell you a trade secret. In any subject, there will be a lot of theorems. There will be hundreds of definitions, 40, 30, 40 big theorems, and so many lemmas, and hundreds of exercises. Okay, somehow we go through, pass the exam. Okay, I'm happy. But if I want to practice mathematics, let us say I want to go for higher studies in mathematics, I may not remember all of them. Then what do I do? In each of the subject, you look at some basic concepts you learn thoroughly. After that, you look at something like that, about 10 deep theorems, which it kind of introduces you to typical tools of the trade of that subject. Typical trade in analysis is estimation, divide and conquer, or curry leaves, or this kind of thing. So take these about 10 theorems and master them. If you necessary, go through it twice, thrice, 4 times till you are very confident. Once you are done that, you will see analysis means this. Then I should be able to prove. Okay, just give me some time. I can quickly refer if necessary. I can prove it. That's the confidence you will reach. I hope this helps. I hope you enjoy. Okay, have a good day.